to the other room down the corridor, and that's an immediate after school detention. So, up to you. I'm not going to give you any warning. Just get your act together and be quiet now, please. You can be absolutely brilliant when you want to. And last lesson, when you did the practical work, I was very, very pleased with the way you conducted yourself. That needs to be replicated in this room when you come in here at 6. Now, nice and quiet. Now we're going to move on.
I did miss Harry Potter by then.
Okay, so I'm going to start the practical part and how you both constructing my lesson. Harry, get outside. Surprised how many people want after school detentions. You definitely have an after school detention now. Out you go. We'll come out for your work in a minute. Yes. Didn't do anything apart from be a complete idiot at the beginning of my lesson. I'm not having it. Miss Gilliam, in a minute when we've got our work, you can take it out. Harry will be in with his flipping or something. I need to look on the referral content. Perhaps you could look that up for me, could you? Because I want to start my lesson. Right, okay, so you've got peer assessment in here. You've done that because we started machines. You did your, remember, right back at the beginning, we did about machines, then we did about motion. We get a summary of everything. So you've done your peer assessment, and in your book, remember when you did all the things about different engines and the different types of levers, you did that poster, you should have that in your books somewhere. So we've done that, but the idea is now, today's lesson, it will be a summary of your work. So in this one, there are quite a lot of questions to answer, and there's mark schemes, and there's a summary motions questions, and there's also summaries machines questions. So the more you get through, the less you're going to have to do at home. So in this lesson, you've started 25 past now, you have got 35 minutes, which should be long enough to get both, or at least a good way through the second one. You have a yellow self-assessment sheet for Harry. You've got to do one of those. Don't talk, please, or else you will be sent out as well. Oh, right. Yeah, it's Miss Rees, yes, thank you. Needs to do those questions and finish them off for homework. If you need some mark scheme, oh, could you take...
Is this magic trick?
Is it necessary for you to interrupt me when I'm talking to Miss Gilliam here? Then shut up and get on with writing your objectives down and your dates. Right, okay, no talking, but this is a little confidence sheet. You need to stick this in. It's just about whether, can you calculate speed? Now, I was going to give you a little test, but I would rather, at the moment, just give you, verbally ask you to write down in your book what you think the equation for speed is without looking it up. So write speed equals, and write in your book as a starter, okay, what you think speed is. Speed equals, spoiler, right, yeah,
Spoiler.
No, don't shout it out, because that means that you're telling somebody else. Right.
We have to say
Have you got a question?
shut up.
What do you know?
Is it bad? Yeah, that's what I thought, babe. Isn't acceleration speed divided by time?
No talking, thank you. Yes, I will.
Shut up.
Then you shut up, yes.
What is how to calculate the universe using
Okay, boys, I'm going to split you up, put one of you over there, unless you
Oh, it doesn't have
Give yourself a 5 for everything. 5 is the best score.
No, it's not. It's the worst.
It's the best score. Here you are. Mentally blind. Shut up. That's why 5. Pussy.
So I was in a
5.
and you play blackout.
Do, do.
So I kicked him right in the
I still see the shadow of my
Okay, Marcelli, do you want after school detention as well? Stop singing, get on with your work.
I did. Okay.
Have you done that?
Yeah.
Right. Okay, in your books you need to write down the equation for speed
I did that, miss.
and then the extension one. Can you remember the equation for acceleration? Acceleration equals. I know Harry knows it, so I know one of you knows it. You've all been taught it, you've just got to think it what it is.
Acceleration.
So if you're accelerating, you need to know that you have got a change in your speed and you need to know how long it takes you. So acceleration equals, Harry?
Accelerating with final speed over time.
Your final speed now, it's your change in speed. Final speed would be okay if you're from stationary, because that would be from 0 to say 50, but it could be that your change in speed is from 50 to 60. So it can't just be final speed, it has to be your final speed take away your initial speed, which could be 0 or it could be 10, 20 or whatever. So acceleration equals your change in speed or change in velocity, technically, over time taken. What are the units, Hakim, for speed? The units. What do we put? When you put 20, how do you know that speed? What unit did you put? Do you know what I mean? Maybe I'll start back? Yeah. Hakim, we say, okay, so we said meters per second. The unit. Yeah, that's the unit. That's what we call the unit. Okay? So what is the unit for acceleration then, Lewis? What do we measure acceleration? This is a summary, this is revision, this is something you should learn, and this is something I want you to think about. Speed is measured in meters per second. What is acceleration measured in? Units. When I ask you what a unit is, Harrison and Bobby, I'm going to split you two up. You're not supposed to be sitting together anymore anyway. When I say units, I mean is it meters, is it seconds, hours, kilometres, kilograms. Those are all units of measurements of things. So what is acceleration in Chelsea?
Is it meters squared?
Meters, yeah, just a bit round the way. Meters per second squared. Good. And what that means is meters per second per second. Meters per second is your speed. How is that changing every second? How is your speed changing every second? That's why you've got meters per second, meters per second squared. So those are your two equations. Right, it could be me and start getting you to rearrange them, but for foundation you would not need to rearrange equations, you would be given those. But if you want to go into the higher sets and want to sit higher, which some of you undoubtedly will go into the higher papers for physics, you will be expected to rearrange equations, so just to let you know that. So when you've done that one, I'm going to start you off on, there's motion one, or there's machines. So you have a choice. I think the motion one's a little bit smaller. We'll start with motion one. Questions? So you will be, let's say, 5, 10, 15, 20, 25 minutes, 35, 5, 10, 15. You get 15 minutes on this one, and then you can have 20 minutes on the other one. Okay, you're a keep watch. I know you're doing something under the table, so I'm start using it. I don't care if you have after school, so I've got somebody in already. I'm more than happy to put people in after school. So, you speak to yourself.
You did nothing, miss.
I can tell where your face is doing
I can do it.
Right. See how close you are, you help each other with it.
Bin Laden.
What?
After school starts, free.
Why?
I couldn't tell you.
Question number 1. Let's focus. Like I say, the more you do now, the less you're going to have to do at home. So better to work now, and then you've got get through both of them. So question 1. The 2-second rule is a rule for car drivers. The rule is as follows. Leave enough space between you and the vehicle in front so that you can pull up safely if it suddenly slows down or stops. You sometimes, when you're going along the road, you see little chevrons in the road, and it says keep, especially going up to Oxford, where the A34, they've got chevrons in the road. Those like V's marked on the road, and you can you have to keep 2 apart. So it's telling you how far you've got. People drive very, very close to each other, and if they suddenly stop, that's when you get a pile-up. Okay. A 2-second time gap may be sufficient. Use stationary objects, e.g. lampposts, to help you keep a 2-second gap. So, if you're driving along somewhere, you can use the lamppost. Use something to give you yourself that 2 seconds. As an experienced driver, you know if you're too close. My husband drives a lot through London, and they drive about an inch off everybody's bumper. Out in the countryside, we give each other a bit more space, but he doesn't. When he's in the countryside, he assumes that he doesn't let people in. Because in London there's a different way of driving. Because you let a slight bit of space, somebody's going to take it. Okay, London's crazy. But down here, people are a bit more polite. You can allow yourself a little bit more room and to allow it. And in fact, the other extreme, some friends of mine said they'd moved down to a place near Bournemouth. And Bournemouth is quite a retirement area. And they said it drives them potty because they get to a roundabout and everybody is slow, so slow, because everybody's, oh, after you, and after you, they're sort of too polite. So there's a happy medium where you're driving sensibly with a big enough gap, and you've got the 2-second rule. So it says the traffic is moving at 20 metres per second and the driver is keeping to the 2-second rule. What is the distance between the driver and the car in front? Okay, I don't want you answering it, I want you writing it down. I just want you to explain that first question. So the traffic is moving at 20 metres per second. The driver is keeping to the 2-second rule. If he's driving at 20 metres per second, how many metres behind does he have to be if he's got to be 2 seconds behind him? Okay. Okay, number 2, the traffic increases to 25 metres per second. But the driver stays the same distance from the car in front. She sees the car in front pass a lamppost. How long would it take her to reach the same lamppost? Okay. I'm not telling you answers, I want you to think it right down. Have a go, and if you get it wrong, that's fine. We're going to have mark schemes to look for it in a minute.
7
Driver C, the driver decides to check her speedometer while driving along a motorway. She measures how long it takes her to travel 6 kilometres. It takes exactly 4 minutes. What was her speed in kilometres per hour? So she measures how long it takes to travel 6 kilometres, and it takes her 4 minutes. So you can work it out. You've got to change your minutes to hours. Okay, you've got 6 kilometres. It takes her 4 minutes. What was her speed?
25 minutes.
Okay, yeah.
Or bin weevil. Yeah. do you go outside a lot? Okay.
Your minutes you have to put as an hour. So 4 minutes is how many hours? 0.5.
Oh, yeah. Look out here. That's fine.
What was that little rat? It's like a squish ball.
What happened?
Yeah. Well, you said no.
She plays with balls like on FIFA.
How did it?
Right, they're a miss. I guess they're a miss, huh? You got a boyfriend, you get some wine, you got a the double as well. Shut up, blood. You're about to die. What did you get for the first one? First. I got 2 meter. Don't know why. What did you get on the second one? 7 seconds. What did you get on the B? I got 25. What did you get on A?
I got 16.
What did you get for 2? A? It is correct. Yeah, because if you do 4 times 25, it's 60. 6 kilometers. I don't know. Do you play Minecraft? As like the beauty? So the link to your server. The admin. So I can create the /n and hit the server.
I swear, like, everyone plays it.
I don't. I haven't downloaded. I don't play it.
Excuse me, do you think that's an appropriate thing to say to your teacher, a woman of my age? I'm sat here. Do you think that's an appropriate thing to say in front of me? If you do, then I don't think so. I don't agree with you. I think it's very rude, very disrespectful to me.
It's not 32, it's 5. We'll chat, blood. Goodbye.
Okay. These are quite tricky, but this is the sort of thing that you would be expected to be able to answer. Okay? Right, question number 1. Let's just go through these. Question number 1, it should be 20 times 2, because you're going 20 metres every second, but for 2 seconds. So 20 times 2, 40 metres should be your answer. Make sure you've got your unit there. So question 1 should be 40. I think most of you probably got that one. Second one, the traffic increases its speed to 25, but the driver stays the same distance apart. Distance from your first one, which is 40, and divide it by 25 seconds. The answer is 1.65. Have you got that? It's quite a hard one. Who's got that one? I know a couple of people did. 40 divided by 25 is 1.65 seconds. I think that one is.
I'm making this song. So you should have because this back on without school. Actually. Actually recover so we'll do this right.
Okay, question number B.
I'm going to do this back on.
The driver decides to check the speedometer while driving along the motorway. She measures how long it takes to travel, 6 kilometres. It takes her 4 minutes. What was her speed in kilometres per hour? So, we have got 40 divided by 6, 0.067 hours. 6 divided by 0.067 will give you 90 kilometres per hour. Now, there are a couple of you who've done different ways of working that out. Has anybody got the answer 90?
Yeah,
Good.
There's 2 ways of working.
Okay, yeah, so if you've got 90, you can mark it correct.
She's overspeeding this.
Miss, how do you get to the final line?
6 minutes divided by your 0.067.
Another way.
How have you done it then?
So there's 2 ways.
Ben, she asked you a question.
The first way.
No, wait a minute.
How have you done it?
No, I haven't asked that. Just keep your nose out. Right.
I know there's 6 speeds in hours, so I do 6 divided by 4, which is
15, yeah.
I did because it's 6 kilometres.
90, yeah, so you got the right answer just a different way. Good. Question number 2. Speed cameras are used to detect motorists who break the speed limit. A number of lines are painted on the road. As a speeding car crosses the painted lines, the camera takes 2 photographs, 0.5 seconds apart. So they take a picture, 0.5 seconds. What? And then they take another one 0.5 seconds later and they see how far you move. How far did the car move between the 2 photographs? So you've got one line there, you've got to count 1, 2, 3, 4, 5, 6 lines. So it's 2 metres apart, 6 twos are 12. So 12 metres. Don't you get that? You have to count the little white lines. So each one of those is 2 metres. Yes, 2A. Can you see that? You've got 12, yeah, good.
I got
Right, how fast is the car moving? So it's 12 metres divided by 0.5. So it's 12 segments in 0.5 seconds per segment gives you 24 metres per second. So question 2A2 is 12 divided by 0.5 will give you 24. A lot of work going on at the back there. Don't worry, Miss Gillian. Okay, it takes 0.002 seconds to take each photograph. How far does the car move while the speed camera is taking 1 photograph? These are difficult. These are quite. These are probably would be on the higher paper on a GCSE paper, so these are quite hard. So you take your 24 from the previous question and multiply it by how many seconds it takes to take the photo, and you should end up. Has anybody done that one?
Yeah, it comes up something really weird.
What does it come up with?
It comes up with 4.8.
Ah, you've got 4.8 by 10 to the minus 1, 2, 3, 4. Yeah, that's the right answer. Woo. But if you write 4.8 times 10 to the minus 4, what it means is 0.0048. If you put 4 times 10 to the 3, it means you'd have 4 with 3 noughts on it. If it's 10 to the minus exponential, it means you're taking it back down to less than 0. 0 point something. So well done, you've got the right answer there. You've got it is exponential, but you just have to move your decimal point back till it gets to 0.0048. Well done. Okay, C. The speed camera gives out a bright flash to provide enough light for the photograph. How does the light from the flash get back to the camera to produce the photograph? Okay, it's a thing about reflection here. So, Ben, you do this one.
Which one?
A speed camera gives out a flash of light. How does the light from the flash get to the camera to produce the photograph? You know when you're going to say through all the maths and so you have to slow down? Right. Okay, let's take it step by step. The light comes on, its flashes. So speed camera gives out a bright light. It's emitted by the bulb. Okay? It's reflected off the car, because it's got to bounce off something so that it can work out how far it is. Marcelli. Marcelli, can you write this down? This is the answer. If you don't do it now, you're going to have to do it at home. I'm going to take these in and check them. So the light is emitted from the bulb. It reflects off the car because they've got to see how fast you're going. So it needs to bounce off you, and then it bounces back to where? The camera. Good girl, well done. Light is emitted from the bulb, reflected from the car, and detected back to the camera. Okay. Okay, we'll look at question 3. Let's just have a look at it together so that we can focus. So we're turning over to question 3. A video recorder. Oh my God, you probably don't even know what one of those is, do you?
I know what one is.
Yeah. They're old-fashioned machines that stick videos in and watch films on.
No, I don't.
On Netflix anymore.
Miss Alfie's.
Okay, video recorder is loaded with a tape. Oh God, this is old. I think you need to update it. Which plays for 180 minutes. This is a history lesson, okay? History of science. Still used. Some people still use it.
I used to have one when I was young.
The length of the tape is 260 metres. Calculate the speed of the tape in metres per minute. Speed equals... Okay, speed equals distance over time. So 3A1 is easy to do. Just put your distance, 260, divided by your minutes, 180, and the answer is 1.44. So speed equals distance over time. Just put S equals D over T, and then you can easily stick the numbers in later. What is the speed of the tape in metres per second? You have to multiply your 180 minutes times 60 to get seconds, yeah? And then you divide 260 divided by that will give you 0.02. So metres per second, you have to get seconds, you multiply your 180 times 60. I hope you're writing these in as we go along. We're on question 3.2 now. Question 1 was speed was distance over time. To rewind the tape quickly, a different motor is used, which rewinds the tape of a maximum speed of 1.08 metres per second. At this speed, how long would it take to rewind the tape completely? You would have to have the length of the tape, 260, divided by what? Divided by 1.08. And that would equal how many seconds? So 260 divided by 2.08, or sorry, 1.08 equals... Yeah, then 260 divided by that. If you put in brackets 180 times 60, and then 260 divided by what's in the bracket will give you 0.02. No. Which one are you doing?
Miss Alfie's still outside.
I know, so right, it's none of your business. What is your business is getting this written down. If it's not written down, you can come back to our break time and see me. And we'll go through it then. 0.02.
This is the 240. When you put one way down.
Yes, no, 240 seconds. 4 minutes, 1 second. Okay, question 3b2. In fact, it takes slightly longer to rewind the tape what have you got to think about in terms of motion of the tape? That's sort of like an average speed. Why might it take a little bit longer? When you turn the tape on, you probably can't visualise it.
It's got to warm up.
Well, in a way, but in terms of motion,
It's got to reset to the start again.
well, it's got to go from the start to start, so it's got to speed up and get to maximum top speed, okay? Right, last one on this one. Question 4. You have got a remote control car timed over a period of 10 seconds. Look at your graph. A graph of distance against time is shown. What does the line in a distance time graph show you? What does the line of a distance time graph show you? Speed, thank you. So describe the motion of the car between 2 seconds and 6 seconds. What's it doing?
Accelerating.
It's moving at a
steady
constant speed. 9 seconds and 10 seconds, what's it doing? Lewis, look at the graph. You haven't even got the graph in front of you. It's stationary. Good, well done. So, where the line flattens out on a distance time graph, it is stationary. And 4B, calculate the average speed of the car between 0 and 10 seconds. Average speed is your total distance divided by your total time. So your total distance will be, what's your total distance travelled? 18 divided by your total time. 10, no calculator needed. What's 18 divided by 10? 1.8 metres per second. Okay, so that one, a little bit easier, that one, I think, because it's graphing now. Let's just see if we can finish this one, and I'll give you the other papers to start in the last 10 or 15 minutes. Right, see, the diagram below shows two forces. I'm waiting, Lewis.
Why is it doing?
You come back in and you're still talking? The diagram below shows two of the forces acting on the car when it's moving. When the motor was switched off, the car slowed down and then stopped. While the car was slowing down, which of the following was true? Friction was 0 and the forward force was greater than 0. Don't think so, not unless it was out in space. The forward force was 0 and the friction was greater than 0. Friction was 0 and the forward force was 0. Well, the forward force and friction were both greater than 0.
Is it the second one?
It is, well done. The forward force was 0 and the friction was greater than 0. Okay? Because the car was slowing down. It's not actually, I've got a forward force, it's slowing down, and so therefore it's got forward force was 0 and friction was greater than 0. Yeah.
But that's not necessarily always true.
Why?
Because if like there's a boat and it's like going across, in like if it's like low, if it's like fairly easy weather, then it'll go through it fairly quickly. But if it's like if there's friction, more friction, then it would be going slower, but it's still got forward force.
It wouldn't have forward force if it was slowing down. This is what it's saying. Well, the car was slowing, the engine was switched off, so you've not got, if you turned off your motorboat engine, it would be turned off, you wouldn't have a forward force. Okay, the forward force would come from the engine. But at least okay, use the graph to find the time when the car started to slow down. The car started to slow down after how many seconds? 6. Well done, Harry. Excellent. Well done. Good. If any of you want to take a mark scheme home with you to complete your sheets, I suggest some of you do. The next sheet, the next sheet is all about machines, so it's about moments and stuff. So
Luther's text smiley face.
Spell like smiley.
I'm a turned out frown upside down.
This is the second one.
Well,
If you want a mark scheme,
you can't
it's a homework. You know, so do now, you've got 10 minutes. What you get done now.
We have 5 minutes.
Right.
When we do it, we have less than 10
Take
minutes.
that home.
Shut up with 5. Go back. Shut up.
Stop stealing my stuff.
That's for year 7.
I didn't know what it was.
Tyler, what's actually wrong with you? I thought you liked some Tyler one person, but you're like the black. Got the club. That looks like a club, not still has oh, lost it.
I've got a gold stick.
How does that look like a dog?
Okay, so everybody got a sheet.
How does that look like a dog? Yeah, but where's the dog? The dog's a magic.
I heard, but it's flipped.
Okay, question number 1. The drawing shows a very old set of scales. It can be used to check the weights of silver coins. It's like the old-fashioned chemist balance, you know, equal when it's balanced, so it's on a pivot. Rima puts a silver coin in pan X. There is nothing in pan Y. Which direction does pan X move? Down. Or anti-clockwise? Down is fine. Okay, so 1A is down. That's quite easy to fill in. B. Rima puts one coin in each pan of the scale. Which 2 coins will make the scales balance? Give the letters.
D and D.
D and D. Easy peasy, lemon squeezy. 1C. I thought I said Colin. Coin A is placed in pan X. And coin C is placed in pan Y. In which direction does it move? Down. Coin A is 106, coin C is 98. So it will go downwards towards A. Pan X will go down. In another experiment, hurry up, put these in because you won't have to do it at home. We're on question 3, so you couldn't have done that at home now. Question 1, this is motions now. Machines, sorry, machines. Which coin in pan Y gives the letter?
Big car crashes happening locally. Oh no, it's not.
E. Yes, that's correct. E.
It probably is.
Again. I know question E. One E was the answer.
Question E. Rima knows the weights of 5 silver coins and so she also has a gold coin. So now she can use the coins and scales to find the approximate weight of the gold coin. Using combinations of silver coins to make a range of weights, keep increasing the weight of silver coins till they weigh more than the gold coin. The weight of the gold coin is less than the weight of the silver coin, because the gold coin is moving up, but more than the weight that doesn't.
So then, can't you just take away the amount of silver coins by your result? Because then you know what. No, but she doesn't. She knows how much the coin of the silver is.
That's your dad.
Yeah.
What are you doing? It's literally a piece of metal.
And you have an amount. And then you take away how much the silver and then you have gold.
Tyler, Tyler, what is wrong with you?
Take away the amount of silver.
What mental disability do you have?
He's riding the seesaw on his own.
Thank you, miss.
No, I'm playing golf.
Oh, Ben, he sits on a seesaw.
Hi, I thought that was your dog.
It is. She's golfing and
You can be.
Make up your mind.
It's both.
Your dog got crashed by 2 trains. And now it's a dog dog. What is wrong with your imagination?
Depressing.
I'm gonna throw him a little friend. What is Andy doing by himself there?
He changes sides and then he gets a friend.
Yes.
This is Mark. Over the friend. Mark. I should have a friend that nods.
Silver coins on the one side, and looking at what the weight
Shut up.
and then weighing
Good
it
bye.
against the gold coins. And then it's
That's what he can buy.
And it still works.
That's what he can buy.
Question number 2. Right, the other thing is, does anybody else want a mark scheme for the motion one, and they didn't fill in all the gaps? You've done that? No, it's to do now, it's to do after that minute, yeah. You've just gone through these.
I've got
We've got to do
the whole thing for 1 second. 5 seconds. 1, 2, 3, 4, 5. I didn't hold it, and seconds don't go that quickly. I did it in my hand. 1, 2, 3, 4, 5. That's not holding. That's
Today, for today.
Is it place
Wait, Ben.
without your hand anywhere near it?
You're going to steal it.
I will. You will. I'm not listening to
Okay, so finally, question 2A. What way will Dandy sat on the seesaw? Which way does it go? Down. Which 2 people can make the seesaw balance? Ellie and Maggie. Which way on C? A will go up and B will go down. And who could be on the end with B?
Andy.
Rosie or
Andy.
Jack?
No.
Rosie or Jack?
That's not Andy, that's Jack. Jack will never have friends.
Okay, there's quite a few more, we're running out of time, so please take a mark scheme home with you, finish it at home, but write your answers and check them with your mark scheme.
Ellie,
Right. I will be checking your books next lesson. Do you want a mark scheme?
I think I put it in my book. No, I didn't.
look at those friends.
Wait, Miss, can I have a mark?
Yo, look at his trainer, that's some fresh. Yo, those are some fresh Jordans.
My dog is my shirt.
Shut up! Dad went for milk and never came back. Mine went for milk. I want to get some Cheerios. I want to eat Cheerios, but my dad said Cheerios forever. I'm still better now. Shut up!
Whoa!
Get back.
Is that me? Me and me, bro.
Go. Yeah.